Okay, so today what we're going to do is we're going to look at piecewise functions. All right? Is it spelled wrong? Oh, I don't care.
Yeah.
Oh, well. It happens. All right, piecewise defined functions, y'all don't call them like that. So it's just piecewise functions, otherwise known as step functions, and you'll see why in just a moment. So what we're talking about here is we're talking about graphs whose values are constant between a certain set of values. And then they change. Okay? You've done this, you've seen this before. So say like it's, if you buy 3 of something, you get a discount. But if you buy 6 of them, you get a bigger discount, right? The more you buy, the bigger the discount. And so what happens is it makes the graph jump, right? So you're going to see what I mean by that. Now, there are a couple of things that you need to be really careful about with these. It's not hard to graph them. They're very straightforward to graph because it tells you a definite beginning and end, and it tells you the amount, whatever the y should be, the height of each one should be. But you have to make sure that you use the right notation for your end points. Okay? So that's the big part of it. So let's just jump to the book, and so you can look at it and you can see pictures of these. Makes a lot of sense when you see it. Here we go. So piecewise, it is IE. Come on. Piecewise defined functions. So these occurs when you have different rules for finding your y, depending on the value of your x. So the more you buy, the cheaper the price. Okay? So this is page 77. Okay? So here we go. Look at their example, and they'll give you this example of the graph, and we'll talk about this one. It says the cost of having T-shirts printed on both front and back depends on how many you order. The more you order, the better deal they give you. Yeah? If the order is for fewer than 20 T-shirts, the printing cost is $15 per shirt. Fewer than 20, $15. Very straightforward, yeah? Okay, it's a constant value. If it's more than 20 but fewer than 40, the printing costs $10 a shirt. And for 40 or more T-shirts, the cost of printing is $7 per shirt. So let's look at each one of those values and see what they've done on the graph. So the first one is, if the order is fewer than 20, then it costs $15 a shirt, right? Well, here's 20 right here, yes? So when you get up to this point, though, it says fewer than 20. So does that include 20? Fewer than 20? No. So do you see, and it's hard to see on this picture, but there's an open circle or a hollow circle there. That's because 20 is the boundary point, but it's not included in those shirts that cost $15. Right? It's fewer than 20. Now, everything less than 20, all the way there, from 0 to 20, so 0 to 19, right, would cost $15. So here's your $15 is right there. It's halfway between 14 and 16. And so you get this little line there and then an open circle at the end because that is the boundary, but it does not include that number. Okay? Then, if it's 20, more than 20 but fewer than 40, it's $10 a shirt. So you see that the line drops down here to $10. Okay? Now 20 shirts does cost $10, so they put a regular dot like we usually put on. Okay? But when you get to 40, it's fewer than 40. So what do we get at that end? Another open circle, right? Yeah? And then finally, for more than 40. So does that include 40? Yes. So 40 and above. For 40 or more. I'm sorry, I said it wrong. For 40 or more. The way I said it, you're exactly right. Okay? So solid dot, and then it goes, and look what they did at the end. Why? Keeps going that same value forever from that point forward. You could buy 1 million T-shirts and they'd be $7 a piece. Okay? So, all right. So do you see that it looks like it makes little stairs? So that's why these are often called step. Right? And sometimes they go down like this. Sometimes they go up. You're just going to have to pay attention to the values. But you see how easy it is to pick them. Those are your X values, and then the price was your Y value. Yeah, pretty straightforward. Now, so think about those hollow circles, if it's included or not. So think about inequalities. Yeah? And It doesn't matter which value. So look at this. So if we printed 30 shirts, that's the same price as if we printed 22 shirts. Right? So the values stay constant in these. So when you do these, they jump. We did something similar when we did, I think there was one where the kid was saving money and his grandmother gave him some money, so it bumped him up. Remember that? But these, for those, you had she bumped him up. So you had things like this. He didn't have this much money, then all of a sudden she gave him money and so it bumped up. But that's when they were linear equations. So they were either going up or down. Remember that? Okay? But in this case, for these types, these piecewise ones, the values stay constant as they go across. Do you remember that? The grandmother gave the kid some money and it had his savings go up. We did that problem in here. It's been a while. No problem if you don't remember it. We'll come back. Okay? So let's just look at a couple of these in the book and practice. There's nothing weird about these. They don't ever change. That's it. Well, then you answer questions about it, of course. You know that. But it's all right. So then it says the scale of charges is different for printing a small logo. So that means the prices go down. Now, same boundaries if you look at it, but the prices go down. So they put those values on this same chart, okay? But here, instead of $15 per shirt, it's $8 per shirt with just the small logo. And then if you buy 20 or more, it's $7. 40 or more, it's $3. And they've just put both of those on the same graph, which looks a little funny. They should have used two different colors if they did that. And then they ask you some questions, all right, where they talk about the descriptions. So they're going to ask you to describe these. Describe the graph for printing on both sides compares to that printing just a logo. Okay? So, remember when you're describing graphs, one of the most important things you can do you always describe is the y-intercept. Remember we talked about that? It's been a while. That's when we were doing the linear ones. We do the y-intercept. So the y-intercept for the first graph is at 15. The y-intercept for the second one is at 8. Right? The steps are greater for printing on both sides. So if you look at both sides, so it went from 15 to 10. So that's a drop of $5. But this one went from 8 to 5. So that's a drop of only $3. So see the comparison? Okay? And so you just make one of those comparisons. Between 39 and 40 shirts, the cost drops $3 compared to $2 for just logos. So make sure if you're going to talk about the drops or how much they drop or how much difference, talk about it for each step. Okay? Super easy as long as you remember to talk about it. All right. So let's just do one together here. So answer the following. The cost of posting a parcel by air weighed to the nearest gram is shown to the table below. Okay? On the grid, draw the graph of the cost of posting a parcel. So between 0 and 500. Now, 0 to 500. So is that going to get an open circle? Does it say less than 500? No. So it says including 500. So this one, you're not always going to get an open circle. So read carefully. It's $17. So $17, what do we got? 12, 15, 16, $17 right in between two lines. That's really convenient. Okay? And that's if the weight is between 0 and 500 grams. So right here. Yeah? So there you go. And a dot at both ends. Right? So the next one, 501 to 1,000. So you're just moving over a little tiny bit. You cannot show that on this, by the way. I mean, you're not going to be able to show 501 on this. But from 501 to 1,000 grams, so to 1 kilogram, because they're doing the scale in kilograms for you, that's 2150. So 2150, so a little line about there-ish. Who knows, right? This is a really hard one to draw and accurately. Right? But what we'll be looking for on this graph is that you got it in the general vicinity of where it should be, and we'll be looking to see if you put an open circle where you should have had a closed circle. On this one, because they don't overlap. Do you see 0 to 500, 501 to 1,000, 1,000 to 1,500? But what if they did this? From 0 to 0 up to 500, 500 up to 1,000. Up to would mean don't include that. So you would get not a dot, but an open circle. Does that make sense? So they'll give it to you in words. But you can see these, anytime they do that 01 thing, they put 1 on the end of it, that means it's not overlapping. Okay? All right, so you'll just draw the graph. Now, show how you'd use your graph to work out the cost of posting a parcel weighing 0.9 kilograms. What would you do? You would follow the x-axis over to the point where it's 0.9 kilograms, and then go up till you hit the line, and at that line, you would be able to determine the cost. Right? Just like any other graph. And there, one weighing 2.1 kilograms. Yeah? Go to 2.1, go up until you hit the line, and there you'd go. Yeah? All right. Calculate the cost per gram for a parcel that weighs 1,001 kilograms. Now, that's a little misleading, because if they say calculate, that generally does not mean look at the value from a graph. That means plug it into the equation. But do we know the equation? No, so we're going to have to use the graph or just use the chart. Right? You don't have to use the graph on any of these. You can just use the chart, couldn't you? Since they gave us all those values. But anyway, if you're describing it and you're showing you how to use it, use your graph. Talk about the graph, don't talk about the chart. But if it says calculate, I don't see any reason why you couldn't say, according to the chart, that value would be a charge of whatever. Okay? But if it says use the graph, then talk about the graph. Compare the costs of those two parcels, right? Just talk about what's going on. So you would say, so where are they? So what is it? 1,001, so $26 versus $14.99, which is also $26. So am I reading that right? Yeah, they're both within the same range, aren't they? So those two, they would both cost the same amount. Right? Because they're in the same range. Okay. Then they give you a new chart with new values. And then you draw that on that same graph that you just did so you can compare them. Wouldn't hurt. Are they going to let you take more than one pencil or pen or something in there? Yes. You can take everything you want to with this in a clear bag or something like that? Pretty much? Okay. Maybe take some colored pencils. So you could do one graph in one color, one graph in another color, and that way it makes it easy to see which one as you compare them.
So we have to bring our own stuff, but it has to be in a clear zipper.
I think it's got to be in a clear bag or something.
Is it the same for Mark?
Yeah.
Do you wear a uniform for Mark?
Yes.
Why?
Because it's a rule. I don't make the rules. You have to wear your uniform so I'll know who you are, because when y'all dress funny, I can't recognize you. Sorry? No. I'll be there to check you in and make sure that your calculators are right. Well, you don't have to worry about it. You don't use graphing calculators in here, do we? Or do we? I can't remember. No. It's regular uniform rules.
Why?
Because I don't know. It's the way it is. It's not relevant. Come on. All right. Then draw that graph and discuss them. All right. So, guys, just being oppressed on every level today. So here we go. So what I want you to do is I want you to practice a few of these. They're pretty straightforward. So just start with number 2 on page 79. And then 2 through the end. Okay? And those are the last exercises in this book. After that, we're going to start the revision. And what we're going to do is we're first going to revise by topic. And then at the end, we're going to revise by doing practice exam. The whole thing in class. Okay? All right. There you go.